Welcome to Weld.com. I'm going to be running off of the AHP Alpha TIG 200X today. I'm going to be running a lot of stick off of it. We started out doing a little plate here on an entry-level thing about running straight beads and blending them together. I was running 5/32 7018, about 160 amps or so. And this is the first time for me to run this machine, so I want to see what it's all about. AC, DC, okay? So I want to run all these different sizes of rod. I'm actually kind of challenging myself here. My cameraman and I have a bet. By the way, if I stick an electrode, cameraman said he'd give you 10 bucks every time I stick an electrode. So if I miss an amperage or do something squirrely and stick it, y'all collect somehow. I don't know how you're gonna collect, but I have 1/8 inch 70-24. I have 3/32 60-10, 1/8 inch 60-10, 5/32 60-10, 3/32 70-18. I have 5/32, and I'll find something else over there. I think I have some 60-13, and I'll just run everything. So here's my challenge to you. Y'all go get something to drink, grab your textbook, because I need to know what all these different rods run at, okay? You need to know what polarity they run at so you can set your machine up. I can change polarity on this machine by switching leads. I can run alternating current just by the face of the machine. I believe the electrodes are set up right now where if I switched it back over to DC welding, that I would be DC reverse polarity or electrode positive, but I could change that in the DC by just switching the leads. So first thing we're going to run is 1/8 inch 70-24, and I'm going to run it on alternating current, and I believe I'm set at 120. Somebody tell me. Let me get my hood on. I'll check to see what amperage it is, and we'll rock and roll. Be right back. All right, let's give this thing a run here. Let's dance. First thing I'm running is 1/8 inch 70-24. My objective here is to run a bunch of beads and run them all in a very straight line. I'm on alternating current and it doesn't even sound like it. This is the tightest, most impressive alternating current I've ever seen, ever. What I haven't checked yet is see if I can change the frequency in the stick mode of alternating current. If I can, I'm going to be doubly excited. Trying to keep the same width. I'm going to come out here to the edge of the plate, and we'll push back through my pool so that I don't blow. What is that? I want to fill this back over here at the end where my crater is. And well, I have my slag hammer and my wire brush, but apparently I don't need it, because there's my slag. That was fun. Let's do that again. You want to? I'm going to run another weld right next to that one. That bead profile looks pretty good. I am going to give it a little slick 'em up wire brush work there. I'll get to you after a while, I guess. I didn't need to use you at all. Let me check my machine here and see if I've got a frequency change. I'll turn it down to 40. I left my amperage alone, but I did notice that this machine, when I set the machine up, I didn't notice that there was a frequency adjustment for the AC side, and it is active when you're stick welding. Now I think that is like double extra cool. I have not seen that before. Maybe I need to get out more often. I turned it to 60 hertz, 60 cycles a second, which is what I grew up on. Those of you that have welded with alternating current in the past had known that 60 puts out a pretty good buzz. Okay, I did something over here. If you're in my class, I'm asking you to burn all your electrodes down to 2 inches because we need to make good, efficient use. If you have a half of electrode, save it, don't throw it away, okay? You need to learn to do restarts all the time anyway. Yes, I'm making it all the way across the plate with 1 electrode, but if the plate was any longer or any shorter, then I'd have a bunch of half rods. You need to use them up. And I did something over here with an old electrode. It's a trick that somebody taught me years ago. You can take these iron powder rods. If you want to get a good hot burn in over here on the edge of the plate, then stand that rod up there and it kind of acts as a heat sink. Yeah, that part's ugly, but if you look at the edge of this, if I needed to face this off where it was pure weld, it's there. Now, the first rod we ran had some slag peel, but this one at 60 hertz, the flag's off there already. I'm not going to beat the daylights out of it. I don't like people that continually, it's not the people, I just don't like hearing that sound of people banging their plate all the time. And if I did it right now, you'd probably get annoyed and turn this video off. But you need to keep watching because we're going to do all kinds of stuff here. I have a question for you. Okay, we're running on alternating current. Why would I do that? Or I should say, what is the biggest advantage of running on alternating current with 7024? Those of you that have done beam work, putting base plates on beams and stuff like that, you might get to this answer real quick, but there's a challenge right there. You can put it in the comments. The question is, what is the biggest advantage to running alternating current with 7024 or 7018 or any electrode that runs on alternating current, okay? I'm gonna change this frequency and go real high with it. I'm gonna turn it up to something. Don't know what yet. We'll find a good number. Change the frequency to 170. Now this I can hear. Pretty tight sizzle. I'm going to tell you this right straight up. Normally alternating current puts out a pretty heavy spark. A lot of BBs, a lot of spatter. Everything that's coming off of this is pretty small. Very small sparks, very small, let's call them dingleberries, you want to? Now, here's about the time where I need to go cool this plate off. We're saturating it with heat, running multiple beads. I'm going to switch rods and I'm going to change amperages. I'm challenging myself to guess and hit the amperage for the size of rod that I run. I haven't decided what I'm going to pick up yet. I switched the machine over to DC. I've changed the amperage down to 80. I'm getting ready to run a 6010, 1/8 inch 6010. This was the slag that we had coming off of the 1/8 inch 7024 on alternating current. This slag here, this is a 7024 is an iron powder rod. Got a lot of iron powder in it. It's like a production rod. 24 indicates that the 2 in that numbering system tells you that it's flat and horizontal. 6010 is a violent digging, fast freeze type of electrode that has a cellulose type flux to it. Cellulose sodium, by the way. It runs on DCEP. Okay, so when we strike an arc with this, I want to drag this forward slightly, and I just want to barely lift up so that it'll flatten out. It's just it's my personal thing, but I kind of run it in a gentle stitch rocking motion here. Let me get going and we'll show you what we're talking about. Again, doesn't matter what electrode, you need to be running straight lines. Same width, try to keep them straight. This is interesting. I'm holding a pretty short arc, and my arc is going out. Come on, sweetie, you can do it. I am gently touching the rod on the plate all the time, except when I'm lifting up. Oh, this is interesting. First thing I'm going to do is check my ground, check my connections. I am going to finish this bead whether this machine likes it or not. Haven't seen that in a while. You're not going to get any slag peel with 6010, at least I never have in my entire life. If you do, let me know. Oh, I want to witness. It's a light, flaky slag. Little spatter. 6010, 7010, 8010, 6011. They're all kind of like a fire-breathing dragon. They put out a lot of spark. Give me a sec. I want to check some things out on the machine here and find out why that was kind of cutting out. I switched the amperage up on this to 85. I twisted leads and couldn't find anything. I'm running this rod with barely any motion at all. I'm not stitching. I've had about enough of that. Short fuse that I am. I'm going to switch to an 1/8 inch 6011. What's the difference between 6010 and 6011? 6010 is high cellulose sodium, runs on DCEP. 6011 is high cellulose potassium, runs on alternating current or DCEP. Let's try the 6011 to see what happens. Almost had a stuck electrode. $10 from the cameraman. Well, I'm able to pull off my little stitch here. Plus I'm long arcing. You can take a 6011 and gouge and long arc. There we go. Well, I'll have to research that and find out what's going on. I need to clean this up. Kind of ruined our beautiful plate here. We've got a lot of spark stuff. Let me go clean this. I need to clean mill scale off over here anyway. Be right back. I left the machine at 85 amps. I was running 1/8 inch 6010, 1/8 inch 6011. Now I'm running 3/32 7018. Does that run the same amperage? Why would it? It's smaller rod. Why would it be the same amperage as an 1/8 inch 6010 or 6011? And by the way, the polarity, correct polarity on 7018 is alternating current or DCEP, which is electrode, or I'm sorry, reverse polarity. It's electrode positive, reverse polarity. Now, why would this, even though it's a smaller rod, why would it run the same amperage? Because it has iron powder in it. It takes a little bit more amperage to combust this. So the cool thing to do, I remember when we worked in the refinery a lot and we were up in the racks or away from our truck, cool thing to do was pick a combination of rods that you could, you know, minimize going back to the truck and making amperage changes for. If you had a bunch of 6-inch pipe, schedule 40, I'd usually run 1/8 inch roots, 1/8 inch hot pass, switch to 3/32 to do my fill and cap if I needed to do a fill and cap. If it was larger diameter and or schedule 80 or thicker pipe, a lot of times I would run 5/32 6010 and 1/8 inch 7018. Those two run about the same amperage, okay? See, you just learned something. How cool is that? I haven't stuck a rod yet. I know the cameraman is getting nervous, so maybe I'll do it on this one here.
Ooh, almost. I heard him flinch over there. No stitching with this rod. Simple drag motion. I just thought of something. Wonder how that is. I always think of cool stuff when you're welding, when you're under the hood.
Not able to make it all the way across the plate with the 332. Slag peel, almost. It's a beauty. Let me check something on the machine. Be right back. What I had thought about while I was welding was maybe there was a dig feature on the stick part of this, and I didn't find one. So again, I'm new to this machine, so I'm not scared of it, but there's a lot of bells and whistles on there. We need to learn all the adjustments. Okay, I welded almost all the way over to the end, and I'm not able to, I ran out of rod. So instead of restarting right here, I'm gonna cheat a little bit and turn this back around, or I could just switch hands and I'm gonna strike the arc and come back over and stop on top of that button. How about that? That's another point. You can learn one-handed. When you're learning, brace yourself. Don't try to do it all out here. We'll get to that later on, like when you're running in grooves. Brace yourself so you can be steady. After you get good with one hand, you can switch hands and run the opposite way. Learn to run both hands, I should say, not the opposite way. Good at times. It's good to be able to run with both hands. I can tell you a funny story about me teaching myself to weld pipe with TIG with both hands. I taught myself on a 1958 SA200, Lincoln SA200 crank machine. One of the smoothest machines I've ever welded with in my life. Turned about 1,750 RPM. No amperage control other than it's electrically hot all the time, so whenever I barked up on the struck an arc, whatever I had the machine set at, that's what I had, so you can't have a foot pedal save you. Anyway, I was teaching myself how to weld pipe in my garage, got real good at it left-handed. Switched over to do both hands and switched over to right-handed, and it was rough. Looked like a monkey molesting a football there for a while. I mean, I just went through tungstens and couldn't get started, and then it was so bad. It's kind of like me trying to get up on one water ski for the very first time. I mean, it was just horrible. Well, then all of a sudden I got it, and I'll tell you how I got it. I was thinking about it driving down the road. I just, you just feel stuff come to you, and I realized what I was doing wrong. Anyway, I got real good right-handed. And then I thought, wow, I got this down. This is cool. switched back over to my left hand, and I couldn't weld left-handed to save my life. Short learning curve though to bring it back to left-handed. Anyway, I thought that was funny because it happened to me, you know. Okay, we've done 70-18, 60-10. We've run AC. I need to switch something up here and go DC-EN. So I'm going to switch leads. Probably go back to the 70-24, or if I can find some 70-14, let me get that on board. I couldn't find any 70-14, so I substituted some 60-13 for you. I switched the leads. I'm over to DC-EN, electrode negative or straight polarity. 60-13, what polarity does it run on? Correct answer would be any. That's the correct answer on the test. They run any polarity. Does it run different on each polarity? Sure it does. On EN, it tends to deposit quite a bit more material, heavy deposition here. Got a rutile flux in it. Now, the numbering system, 60-13, 60,000 pound tensile strength. The 1 means it runs in any position. The 3 indicates the flux and the electrical characteristics, okay? Any position. Would you run this rod uphill? Because I don't like running it uphill. I like running it downhill. It's not a heavy penetrator. It runs good on sheet metal EN downhill. You can run it hot. Doesn't make a real crowned up weld when you do it that way. 70-18, same thing. 70,000 pound tensile strength. It has a 1 in the 3rd digit, which means it runs in any position. Would you run 70-18 downhill? I don't. I hate it. I love running it uphill. Doesn't run worth a hoot downhill for me. Slag runs down in front of my pool. Get to know your rods. Get to know the characteristics of your rods. Polarities, setup, amperages, everything. Doesn't hurt to know this stuff. All right, let's run another bead here. Yeah, again, DC-EN.
Turn this machine up to 105. This is not a rod that you'd whip around either. Straight drag is fine. Gently touching the plate all the time, same pressure, which is very light, by the way. Pretty quiet, runs pretty good. Ooh, ooh, ooh. Anybody know what that is toward the end? I'll give you a clue. It's the answer to one of your questions that I asked you a while ago. And what is that? Again. I believe that would be slag peel. Kind of like it when that happens. One more. That was so much fun. Let's do that again. And then we're going to do a little experiment, little test here, see if we can have some real fun. All right, here we go.
It didn't do it quite as bad at the end of that one, but it wanted to, it started to. So here's the point. We ran a bunch of different rods. We ran multiple amperages, multiple diameters, multiple polarities. We didn't stick a rod. The cameraman's happy because he's not shelling out large amounts of cash. So let's try one more rod. We'll go back to 7024, and I want to try something. I used to do this in demonstrations. I don't know if this, I know this 7024 has been sitting out for a while, but I want to see if we can do this. We used to do this with 7024 and 7027. Strike an arc. You know, when I was growing up, you know, I started welding school when I was a junior in high school, and I won't say we were punks, but we had a sense of humor. We liked to have a little fun. Somebody figured out, take a 7024, strike the arc, and just lay it down on the plate and let it run by itself. And a good fresh rod will actually run pretty good. That's how we used to cheat on our weld test. Let's see. I want to switch back over to. I got to switch back over to. You know what? I'll just do it on DCEN. But I need to go up to like 150 amps. I'll go DCEN 150 amps, 1/8 inch 7024. See what we have. There's a little more spatter around the rod. You know, it ran. A little different ripple pattern in it, a little longer. I guess the point to make there would be, you know, a good short steady arc, and you're directing that in there. Some of these iron powder rods, they're very forgiving. You can lean them quite a bit, and they're pretty good. Generally, if you're keeping a rod 20, 30 degrees pointed into your work, you're fine. You know, you're getting the arc stream in there. You can gently drag it on the material. You know, if you're in a groove situation and you're going uphill with 7018 in a groove, the ability to feel dragging the rod on the leading edge of the pool with your rod 10 degrees forward, straight in, 10 degrees downhill, you'll be fine. You'll be making quality welds all the time. So again, you know, we ran a bunch of different rods, different polarities, different sizes, different amperages. The AHP Alpha TIG 200, pretty impressive. What I really thought was cool about this was the ability to change stick welding AC frequency. I don't think I've ever been on a machine that would do that, and I see some advantages to it. You need to answer in the comments, why would you run alternating current? What's the biggest advantage of running alternating current stick welding? I hope this helps. I'm Bob Moffett with Weld.com. Thanks for watching. Make sure you subscribe to the videos. New videos come out every week. Thanks for watching. Whew, that was brutal. I was checking the machine and there was an explosion. I don't know if it came out on audio or not. Wow. I feel better, I can tell you that. I'm kind of lightheaded.
All right.
All right, you ready?
Yeah, ready.
Okay, I'm just gonna laugh a while. I don't know if I can weld while I'm laughing, but I'm gonna sure try. Oh, it's getting late and we're getting goofy around here. All right, let's give this thing a run here. Let's dance. I can't win. All right, here we go. I'm hoping we're rolling here.